Welcome you all. In this session, we are going to discuss in detail about the materials used for electrical machines design. The main material characteristics of relevance to electrical machines are those associated with conductors of electric circuit, the insulation system necessary to isolate the circuit, and with the specialized steel and permanent magnet used for the magnetic circuit. So the material that associate with electric circuit, magnetic circuit, and the materials which is used to isolate the circuits. These are the major materials we require for designing any electrical apparatus. So the conducting material. Commonly used conducting materials are copper and aluminium. Some of the desirable properties of good conductor should possess are listed below. Low value of resistivity or high conductivity, low value of temperature coefficient of resistance, high tensile strength, high melting point, high resistance to corrosion, allow bracing, soldering or welding so that the joints are reliable, highly malleable and ductile, durable and cheap by cost. So these are the properties that a good conductor must have. Second is magnetic materials. The magnetic properties of magnetic materials depend on the orientation of the crystals of material and decide the size of machine or equipment for a given rating, excitation required, and efficiency of operation. Some properties of good magnetic material should possess are listed below. Low reluctance or should be highly permeable or should have a high value of relative permeability, high saturation induction, high electrical resistivity so that eddy EMF and hence eddy current loss is reduced, narrow hysteresis loop or low so that the hysteresis loss is less and efficiency of operation is high, a high Q point so that the loss of magnetic is magnetic property or become paramagnetic, that is effectively non-magnetic. Should have a high value of energy product expression expressed in joules per meter cube. Magnetic materials can broadly classified as diamagnetic, paramagnetic and ferromagnetic material. Antiferromagnetic and ferromagnetic materials too. Only ferromagnetic materials have the property that are well suitable for electrical machine. Ferromagnetic properties are confluent among almost to iron, nickel, cobalt and their alloys. Further, ferromagnetic materials are again classified into hard and soft magnetic materials. Hard or permanent magnetic materials have a large size of hysteresis loop and gradually rising magnetization curve. Example: carbon steel, tungsten steel, cobalt steel, alnico, hard ferrite, etc. These are some examples of hard or ferromagnetic materials. Soft magnetic materials have small size hysteresis loop of a steep magnetization curve. So the cast iron, cast steel, rolled steel are some examples in solid form. Silicon steel is limited form. Addition of silicon in proper percentage eliminates the aging and reduces the core loss. Low silicon content in steel or dynamo grade steel is used in rotating electrical machines, and high content of silicon steel are used in transformer grade steel. In transformer, high content silicon, and rotating machine, low content silicon is used. So other classification comes under special purpose alloy. Nickel iron alloy have high permeability and addition of cadmium lead to improve the magnetic material. Nickel with iron or different proportion leads to high nickel perm alloy and low nickel alloy, and these are the various combinations of special purpose alloys. Amorphous alloys, often called as metallic glass. So the amorphous alloys are produced by rapid solidification of alloy at cooling rate of about a million degree centigrade per second. The alloys solidify with a glass-like atomic structure which is non-crystalline frozen liquid. The rapid cooling is achieved by causing the molten alloy to flow onto the rapid rotating water cooled drum. This can produce sheets of thin as 10 micrometer and meters or more wide. Next is insulating material. So the following properties need to be possessed by the insulating material. They are: should have high dielectric strength, should have withstand high temperature, should have good thermal conductivity, should not undergo thermal oxidation, should not detonate due to high temperature and repeated heating cycle, should have high value of resistivity, should not consume any power, or should have low dielectric loss angle delta, should withstand stress due to centrifugal force, electrodynamic or mechanical forces, should withstand vibration, absorption, bending, and should able to absorb moisture, should be flexible and cheap. Liquid insulator should not evaporate or volatile. So these are the basic properties of an insulating material. So again, the insulating materials are classified into various classes: A, B, A, E, B, F, H and C, and the maximum operating temperature based on the temperature withstand capability. So if it can able to withstand up to 90 degree, then it comes under Y class. If it is up to 105, it comes under A class. If it is 120, it is E, and if it is 130, it is B. If it is 155, it is F, and 180, it is H, and if it is more than 180, it comes under C class. And various typical materials and examples has been coded under the corresponding classes. Thank you.